Hello, hi guys, welcome to my channel. Okay, today I'm gonna present the project about secured supply chain monitoring for real-time inventory tracking and demand protection. At the company I'm carried out is Vethika Enterprises, so which is the company logo. Okay, introduction. So we can see the secured supply chain monitoring for what purpose. It's a transparencies, efficiencies, and predictive capabilities according to stockout problems. So I took the company. It's a very enterprise. So my company is a production based company. It's a Sambrani products like Sambrani dope, Sambrani powders, and incense sticks. Incense sticks are nothing but it's agarbatti, or it's called uzbatti in our regional language. So I find out the major core issues in that company is stockout problems and excess of inventory and inaccurate forecasting. So these are my major problem identified in the company. So no real-time tracking. So no real-time tracking leading to the delayed decision, delayation and stock discrepancy. And inventory mismanagement majorly causes the stockout problem and overstocking problem. If you maintain the inventory, you can minimize the inventory holding cost and also warehouse holding cost. So in our project, I got a company in Vethika Enterprises with three major problem identification with no real-time tracking and overstocking and stockout problems is frequently occurred in regional based. For example, it's in any products is like in Tamil Nadu. So some demands are in Bangalore, some demands in Andhra Pradesh. So we can't maintain the inventory management. So this system lack of transparencies and traceabilities of what where is my project batch in that company where it to be go to Andhra or Bangalore or anything else. It's only the control of a such a department of logistics only. So we can carry out the three major problems. So, and finally I sort out the problems with 16 percentage I can solve that problem. Okay, my main objective of my project is it's a integration of quick response code, thing like that. It is a QR code. So in QR code, I implement the novelty of my project to secure supply chain monitoring. It means I have enclosed with blockchain technology with the QR code to secure the transparent tracking of each batch metal of raw materials and finished goods. It's allow for tamper-proof traceability across the supply chain management. So we develop the multi-linear regression model. So linear regression, you can know it why it is used to predict the demand. For the demand prediction, so if you know the demand, you have handled the inventory stock. So if you better handle the inventory stock, obviously, stockout problem and overstocking problem is reduced. So that's only I put it in the slides. After that, I choose the six variables from my raw data set from the company. So I use the secondary data set. So is this six variables I can choose it from a common names from the source of literature these papers. So I read this paper of abstract to whether how it is me handled and delivered to the outcomes. So I choose these six major independent variables. So sorry, six major independent variables and one independent variables of inventory turnover ratio. So you can calculate the turnover ratio of cost of goods sold, how much product is sold, and by inventory cost. In the business gap, we can only focus on blockchain for traceabilities and analytics for forecasting. In some research papers, I can clearly see there only QR code with the ERP systems to optimize the supply chain tracking. Other than that, it's only demand prediction of linear regression or logistic regression to hold the demanding stock or forecasting the stocks. So no, I only few people are embedded with the real-time tracking with the blockchain technology. So in my project, the novelty of my project is to hybrid approach, like an real-time QR tracking powered with the blockchain SHA 2 physical encryption. SHA means secure hash algorithm of 256-bit encryptions with a regression based prediction model. So we can combine the blockchain QR code tracking and regression based prediction tunnel to sort out the problems of real time inventory tracking and stock out the problem. So in this research, you can use the predictive for the demand prediction and exploratory because of the SHA to physics QR code analytics. It is whether it is goods or not. So after implementing the SHA QR code tracking, so we can use the exploratory methodology. So data source is always secondary data from a company internal logs. So sampling method is a stratified sampling. Why it is stratified is because my raw materials and my raw data and other anything from logistic based and material based all products with different categories like a different location from different raw sources, so we can use the stratified with sampling. So stratified means it's data across from different categories, not only a single category. So different categories I can use we can use a stratified sampling. Data collection method from November to April. November, sorry, I mean I didn't mention the year. So it's November 2024 to April 2025. So technology we can use obviously Python for both encryptions and QR code creations. So in Firebase we can serve the QR codes and store it from any devices like an systems or any laptop. So I didn't have laptops and systems in the company. So we use the Google Cloud to store the QR codes and blockchain based data in the Firebase technology. So we can use Visual Studios for programming SHA2 algorithm and QR code encryptions. So this is a major important things to initialize the project. So if you, one of them from any, for example, if you are a like what if you are a manager, you can authorize the whether who can see the your data like an low management has three types: high level, low level, middle level. So high level managers only access can see the whether the product batch is where to go and which can be analyzed. But low level peoples only can see the what are the batch you can hold it up. That batch can be transported to one location to another location only. So that's only we can segregate the three types. So we only focus in high level management only. So in that the name, phone number, email address, username and the passwords are fully encrypted. Sorry, fully encrypted with the blockchain, and only passwords are encrypted with the SHA 256-bit encryption. And if you enter, if you select the data, if you type the data and create the, if you click into create account, it is directly redirected to the Firebase database. It's in the Firebase database. It's a real-time database. So I can use a Praveen Kumar MIT and the database and the phone numbers. It's all in there. So in needs a 64-bit of characteristic is a SHA-256 encryption for real-time supply chain tracking for block. So password is converted into eight words or 16 whatever you type in this your passwords. So it can be converted into 64-bit of strings. So it cannot be decrypted because of a hashing, cryptographic hashing of SHA-256. So we can use the QR plus the blockchain implementation. Blockchain enables the QR code tracking. For example, if you any manager scan the QR code, it will directly to what batch is sent to Bangalore, what batch is sent to Andhra Pradesh, what batch is to sent to Pune. So we can easily traceable the systems, and we can store the QR codes in each and every days or each and every month in a Firebase database. It's I think so. It's in 1 TB upload storage. Whether it is any error of my words, so can you please clarify me? So that data is encrypted to two physics algorithm and stored in the Firebase database. It's so we very first beneficiary for that ideology. So real-time tracking inevitably easily occurred because of the QR code encryption. So in the way that's only I mentioned is the product and the blockchains. So product we can see the Chambrani 33 also. So in the screen you see the blockchains for a plot Sambrani 33. So you can see the all the details about the sensitive data like hash values. Like hash value is not a sensitive, like an locations and product ID, product name and shipping carrier, supplier name and the timestamp. So the supplier name, carrier, supply, shipping carriers, timestamp and location, it's a very credential, very sensitive credential for the company. So that's only we can put it in the blockchain. If you scan with the low level employer, like scan the QR code, it's you see only in the product base. It's in the company roots of 33. If you click the 33, you can only show the inventory tracking of how much raw materials are there, where to be it can be supplied. That's only the details see in the low level management. So these are the QR code creation of using such a encryption with a Python code in Visual Studio. So each batch can be separated with this unique QR code. If you scan the any QR code, it can be reflected about the batches and where to be shifting the warehouse to delivery location. So with all the products can be all the product details can be embedded in the this type of QR code. So that's only so this is this is the this product Sambran Dupe 33. This is the Sambran 33. I'll maximize the image of a QR code. So if a manager of a higher level, for example, product manager, logistic manager, they can see the where the product is to be delivered and how much the raw materials can be maintained in the inventory. So we can easily scan with the mobile application. So easily, if you scan the QR code, it's really redirect to the product details like an initial stock, how much initial stock is there, production volume of is there, order quantity is there, how much raw materials and the defect rates. Defect rates, it's not worry for the stock out problems and the overstocking problem. I can clear it later in this slide. So it's you can see all the drills in the systems. So in blockchain history, you only can see high level management only. For an example, location, shipping carrier beam, supply name, where to be supplied, who can be access the items. So after that, the current inventory deals also reflected in the system. So how much the raw materials are there, how much the essential oil that's there, how much the okay herbal mix is there. So all the data can be reflected to the QR code. So we can easily manage the how much the raw material is left in the system, left in the company. Yeah. So we can successfully implement this supply chain tracking, secure supply chain tracking for real-time inventory tracking, and after that we can predict the demand. So if you can predict the demand, you can easily analyze the stocking problem and excess of overstocking problem. So in that I can use the correlation method. In the correlation we can use the Pearson because of fully of numerical values. We can use the Pearson correlation. So many correlation as there is better to use the PCA like a principal component analysis for higher dimensional data. So we can use only 12 columns of raw data. So that's only I didn't consider it's a higher dimensional of integrated data. So whether if you use them Pearson or the Spearman rank method, Spearman rank method is an arrange all the columns in it's a ranking method of alphabetical, for example, ascending to descending, descending to ascending, like that. So if we can in that problem we can use the Pearson correlation method. So we segregate the two correlations for before QR integration of the company, after integration of the company. Before and after, you notice the production volume and forecasted demand. Production volume forecasted nearly to the 1. Before that, it's nearly to 0.94. After that, it's nearly to 1. So, before integration, we can see weaker correlation compared to the after QR code integration. So it's nearly 0.06 0.05 percentage increase in the after QR code integration of the technology. So in Vethika Enterprises, we certainly know about the company because it's only a small scale industry, not like that Amazon and other things like that. So it's not a very large industry. It's only a small enterprises. So all those problems are in the production volume and the forecast. We can easily handle that. For an example, in Bangalore, if you have a high much, very much of production order quantity is there. In Andhra, very low production order quantity is there. We can easily control the inventory. For an example, it's a small enterprises. We can easily with the buffer stock technology. So undo overstocking. If you access with the overstocking in Bangalore, if you want to transfer all the stock to the Andhra, so easily you can send out to distributor to whether where is the demand is high, where is the demand is low. Is only applicable in small scale industry. If you have more than large scale industry, so many of uh, locations you can it be delivered, so it cannot be managed it through too much complicated in the large scale industry. So that's only we can use the correlations and the prediction method. We can everyone you can use the whether it is low or high of demand. So its inventory is good, inventory is low, so we can easily predictable. So my main innovation of the my project is everyone can use the project. For an example, including like small shops, like in small grocery shop, it's like 1 lakh rupees total asset in that shop. So easily address the QR code technology. So not only a QR code to implement the, so each batch can be scanned with the barcode technology. All of the supermarket used the technology only. So whether what is the main course of the ideology is the companies and the any supermarkets only scan the QR code. It's a 2D dimensional only. You can only scan the data about the product ID only. Not can the how much the raw materials are there, how much the inventory is there. So it cannot be happened in the QR code. Sorry, barcode. In the QR code, we can see easily we easily monitor the all the, for example, all the product details and where it is be delivered and the blockchain industry. Blockchain industry where it is to be coming from, where it is to be go. So in current inventory details, you can easily analyze the current inventory details. So that's only we can use the before and after integration of QR code. So in the regression test, we can use obviously regression it comes under the ANOVA and the t-test. In that ANOVA, we use the F static. ANOVA is F static means it's a 33.27. That means 33% of variation in occurred in the total variable of data sets in raw dataset. So we can use a independent variable. Previously I said it's all comes under with the literature paper. So we used a 6 independent variable. That 6 independent variable nearly to the zeros, but the defect rates are more than 0.05. So the p-values is highly significant. Yeah, so it's not considered for the stockout problem and overstocking problem. So that's only purely neglect the defects problem. So we can achieve the R square value of nearly R square value is nearly of 73 0.732. That means 73% of variation in the inventory turnover. So it's a strong forecasting. The higher impact of the manufacturing cost and the number of products sold are nearly zero. So it's a very higher product, very higher impact in the raw material of the stock out problem and overstocking problem. So in low impact where the defect rates are more than the p-values 0.0, it is not significant in the inventory control. So it's not significant. So you cannot consider that it's a major problems in the of a stock out problem and overstocking problem. So enable the accurate demand forecast now statistical data helps reduce the overstocking and avoid overstocks. So we can easily proactive the data driven from the Vethika Enterprises to easily understand whether it is where it be seasonal time, where it will be normal time, easily adapted with the multilinear regression model. So in the diagram, multilinear regression diagram, so you see the actual data and the predicted data from the Vethika Enterprises using a multilinear regression. So model accuracy, the blue dots are really close to the predicted value, so that r square values are 0.73. It's a really good, very good fit, I think so, because of the real time data of so much of mismatch null values are there, some errors are there. According to the 0.73 is so high. For example, 73 percentage of prediction is occurred with a good fit in the predictions value. So before and after, we can clearly see the blue dot lines are nearly close to the predicted value. So that's only it's very simple. For example, nearly so blah blah blah. It's for elaboration of my content. So that's only. So for example, this dot is to be considered as outliers because of a fluctuation can be easily occur in the production based company because of the product in the certain region. So we can see the blue lines the production volume sometimes low, sometimes high, sometimes low, sometimes high because of the production of demand. That the index value see it's time based, how much the time to time, how much the production volume is occurs in the fluctuation is there. So before integration, after integration, before integration of SHA to physics, it's nearly flat and low to the 100 units. So it cannot be prediction. So no prediction means always stockout problem or overstocking problem is occurred. After your integration, forecasted demand is improved. Nearly higher to the 250 units to 300, 350 units. Nearly, I think so. So that fluctuation you can that fluctuations are there in the system. So in that model, the production volume are still variable but closer to the forecasted demand. So all the production volume is closer to the production volume. If you can average the production volume, which is nearly to the 73% of solving the forecasted demand of a stockout problem and overstocking problem. So this show the better alignment between the forecasted demand and the produce, indicating the improved planning after integrating the SHA QR code integration and forecasting the methods. So we can sort out the data of before integration and after integration. High stock out risk are there. Filter the product which is high demand is also high, stock out also high. But on some condition the warehouse inventory is low, and also order quantity is also low compared to the production volume. So in that case, stock out problem is also coming. So because of forecasted demand, so poor forecasted demand and stock out problem and overstock problem definitely occurs. After that, the integration of QR code technology, So you can see demand is also high from the various states, but no stock out problem because of good forecasting demand. So we can achieve the how much inventory can be applied to that department. For example, powder department, soup department, and instance tea. So you can clearly see the demand also high, stock out problem is no, but order quantity is heavy compared to the before and after. This is a before, this is a after. But you can see the various inventory also improved in the after implementing of SHA QR code integration. So clearly you can see before the integration the defects are very low, nearly to the one. But after the integration, it's always nearly to the 2 to 3 because of that app scope of my project. It can be it's also be cleared in the project because of automation of real-time tracking of sensors we can use product delivery. So minimize the problem. So minimize the problem. It's based on the automation skills. So we can deliberately easily attain the stock out problem and overstocking problem, and also impacted with the defect rates. So in that bar graph we can see the red and green. That means overall stock out even before and after in the supply chain inventory. Before that, 100% of stock out integration stock out problem is occur. After implementing the QR code inventory tracking, only 84% is occur. You can easily say, oh, what is it is only 60% of stock out problem is you can reduce. But clearly in mind, keep it in mind because 16% is overall stock out problem and excess of inventory of problem in only in March to April. We only applied the system in March to April, nearly to March first week, I think so, 7th March afternoon 4 o'clock, I think so. We discussed with the manager to implement it in April. April first week, I think so. April second, I think so. To drop the collect the data and we schedule the how it is work. It is good or not. So only 16% we can try in the 1 month of data. So we can easily implement the and increase the inventory traceability. Each product with the tamper-proof QR code. No one can hack the QR code. No one can scan the QR code. So sorry, anyone can scan the QR code, but anyone into the QR code to whether it is a details, where this details, where it is to be delivered. So that can be cannot be decrypted because of SHA encryption. So reduce the problems of 100 to 84 incidents, and the education model aligns the production with the demand. So lower the cost saving, on time product availability. So easily deliverability and decision making for the company. So final conclusion of my project: the blockchain impacted in the QR code technology, SHA 256 encrypted, and real-time Firebase in integration, and enhance the visibility, accountability, and reduce the manual error. It all comes under the impact of a SHL algorithm. So forecasting accuracy, we can use already use MLR for that. So achieving 73% of data driven, and the final result we achieved fewer the stockout problem and overstocking problem. Not fully cleared, only 60% because of only 1 month we can ready up the data. Improved the material control. For improved the material control means it's a raw material of how much the perfume is there, how much the essential oil is there. So if you below the power line, for example, below the 100 units, so it's easily alerted to the dashboard, and the manager can alert. So manager can order the raw material from the sources, different sources. So forecast error can also the so minimize to for the my project. So this is my projects and the implementation and the course audits in my systems. If you can need that and any clarifications there, comment in the YouTube or email it for I put it in the mail ID in this video. So you can any doubts, any clarification, just mail or comment in the sessions. So this is my videos for that. Thank you so much for that explanation. So my English is not well, I because of my pronunciation is not good. So sorry for that. Thank you. Bye bye. Good night.